All right, hello everyone. We're looking at chapter 12 this week, experiments with more than one independent variable. So we're going to make things a little bit more complicated. We've been looking at single independent variable experiments, and now that we hopefully have those down and we understand them, we're going to add another independent variable. Oftentimes when we're looking at explanations for things, there are more than there is more than one explanation, or there's more than one variable present. And those are called factorial designs. And that's what we'll look at here in chapter 12. So we'll look at experiments with two independent variables, which will be able to show us something called an interaction, which we'll talk about. Factorial designs study at least two independent variables. They can help us to test limits. They can help us to test theories. And when we look at interpreting factorial results, we'll talk about main effects and interaction effects. And then we can also look at some factorial variations, things like independent groups, designs within groups, mixed, and then increasing some of the levels of the independent variables. So again, we're making things a little bit more intricate and involved, a little bit more complicated, but hopefully it'll make sense and we can look at what are called factorial designs. So just as a quick review, and this is something we've been talking about now for a couple of weeks, experiments with one independent variable. This is what we've been examining. What is the effect of the independent variable on the dependent variable, and looking at different examples and types of this and different designs. So if we look at this example here, we're asking what is the effect of alcohol intake on somebody's intensity of shock on a scale of 1 to 10. So the independent variable here is alcohol intake. And we have two different levels or conditions, the placebo group and the drunk group. And then the dependent variable would be the intensity of shock on a scale from 1 to 10. And this would be an independent groups, right? We're looking at the differences between two different groups of people. And so this is what we've been looking at. This should look very familiar. We're going to add another layer. And so when we add another independent variable, we call this a factorial design. So what if we were interested in determining if the relationship between caffeine and memory is different for men and women, right? So we could get at that by adding another independent variable. So rather than wondering if caffeine affects memory, that's what we would have looked at up till now. Now we're going to say, is there a relationship between caffeine and memory that is different for men and women? So here we've added another independent variable, which we call a factor. And all levels of each independent variable or factor are going to then combine with all levels of any other factors or independent variables to give us this kind of a really interesting design where we can look at the differences between men and women in the presence or absence of caffeine. So in this example that we're talking about here, on this slide, which is making me want some coffee. One independent variable would be the presence of caffeine. And the two different levels of or conditions of that variable would be that there is caffeine or there isn't, right? It's present or it's absent. The other variable would be gender or sex, which we would divide into male and female. And a good experiment, I would say, should also include other, just for sex or gender, just to be inclusive. But we'd have the presence or absence of caffeine as one independent variable, and then somebody's gender or sex identity, male, female, and maybe other if we were being inclusive. So whenever we are looking at a factorial design, we can have two different types of effects that come out of these designs. We can have main effects and interaction effects. A main effect, another way of thinking about this is like an overall effect. Is there an overall effect of the independent variable on the dependent variable across all levels of the other independent variable, right? So if we have two independent variables in an experiment, we could have two different main effects. So if we were looking at photo type or word type as it affects reaction time, and this is one of the examples in the textbook, we could have a main effect for photo type, and we could have a main effect for word type, right? So we could have a main effect for each independent variable that we're looking at. And the way that we would calculate whether there was an effect or not would be using statistics to see if there's a statistically significant difference between these, which we're not worrying about too much in this class, but you would definitely look at in a stats class, whether that was a math stats or like a psychology statistics. But what you would do is you could graph these, and we'll look at that in a moment, and see if there is an effect or a difference. And in this case, we're looking at that overall or main effect of each independent variable. So is there a main effect for photo type? Is there a main effect for word type? How do those affect the dependent variable? Now, main effects are really important and interesting, but when we are looking at factorial designs, we are a little bit more interested in interaction effects. Interaction effects are deemed to be more important than the main effect. So if there was like one takeaway from an experiment that was a factorial design, it would be these interaction effects. So when we add another independent variable, this gives us a chance for an interaction effect to occur. Whether the effect of an original independent variable, so we go back to that caffeine example, depends on another level of the independent variable. So in this case, maybe gender. So we're asking, when we're looking at interactions, we're asking, is there a difference in the differences, right? Does the effect of caffeine on memory depend on gender? Is there one spot in this little grid where we could say, you know, it seems to be that caffeine affects this population more? So is there a difference in the differences? Is there one level of an independent variable that affects another level of the other one, much more so than we're seeing anywhere else? So rather than focusing on the main effect, we always want to focus on the interaction as the most important in a factorial design. So in a given situation, and I mentioned this in the beginning, it's likely that more than one variable is affecting our behavior and mental processes. We're complicated beings, right? And so it's often more than one thing that's going to be playing a role. So if we look at this example here, and this is another one from your textbook, there's a couple of different types of interaction effects that we can see. And here we're looking at them on like a scatter plot on a graph. Since we're not doing statistical calculations, we can look at them in more of a pictorial like graph form. So in this example here, we're asking, what is the effect of food on how much you like it? And we're also adding another independent variable of, is it hot or cold outside? So we're looking at, does the effect of food type depend on temperature? So the first independent variable here is food type. And it looks like we have two different levels or conditions. We have ice cream and pancakes. And the second independent variable is temperature. Is it hot outside, which is the orange, or is it cold outside, which is the green? So we're asking, does the effect of food type, ice cream or pancakes, on how much somebody likes it depend on the temperature outside? Is it hot or cold? And so if you look at this graph, this is what we call a crossover interaction. And so what we say for a crossover interaction, the takeaway is it depends, right? So somebody's preference on food type depends on the weather outside, right? So you can see that people like certain foods more when it's hot or cold outside. It depends on the weather, right? So there is an interaction effect here that is present, and it depends. And this is called a crossover for good reason, right? They cross here on this graph. We can also get another interaction effect that we call a spreading interaction. And again, nicely named, right? You look at it's kind of spreading apart, right? They're moving in different directions here, depending on what's going on. So here we're asking the question, right? Does a dog sitting, right? The proportion of time a dog sits, is that affected by whether we say nothing or say sit? And does that also have a role when we have a treat or no treat? And so what you can see here is when we say nothing and have no treat, right, across this, there's no treat, like we see very little change in the proportion of time a dog sits, right? And it also, we see the most change up here, right, only when we're holding a treat and we say sit, right? So here we can see that the interaction is the dog is likely to sit most of the time when we are holding a treat and when we say sit, not so much when we say nothing or if we have no tree. So there's certain combinations that are going to lead to a more statistically significant or strong result. And again, this one is called a spreading interaction, as they spread apart from each other, and only certain conditions are creating that interaction effect. A couple of other things here, if we look at factorial designs, you'll often hear factorial designs referred to as a 2x2 or a 3x3 or a 4x4. And so let's look at what that means. A factorial design might be called a 2x2 factorial design if that means we basically have 4 different cells or boxes here on our graph that we're looking at. So if there are 2 levels of independent variable 1, and there are 2 levels of independent variable 2, then we have 4 different cells or conditions that are possible. Another example from your book here, right? Whether somebody is on their phone or not, and there are 2 different levels, so on their phone or not. And then we're looking at the age of drivers, whether they're younger or older. So if we take 2x2, that gives us 4 different cells or conditions that are possible. So a 2x2 design would have 4 different boxes or cells. We could have younger drivers who are on their phone and younger drivers not on their phone, older drivers on their phone and older drivers not on their phone. So we're looking at all the possible different cells or conditions that we could see, and we would call this one here a 2x2 design, 4 different possible cells or conditions. A couple of things, and I mentioned this on the first slide, right? Factorial design can help us to test limits. Where is kind of like the cutoff or the limit? Is the effect of using a cell phone limited to one age group, or do we have the same effect on people of different ages? So if we continue with this example, we have a cell phone condition of people being on the phone or not on the phone. And then we have a driver's age of them being younger or older. And what we're measuring is how long it takes them to brake, right? That is our dependent variable. You can see just looking at the numbers here, there are 2 groups of numbers that seem to play a role, right? But we can look at these graphs and things and ask ourselves, does the effect of talking on the cell phone depend on age? Is there an interaction present, right? And then continuing to test these limits and see at what point is there like a cutoff? Is it limited to one age group, or does it have the same effect of people kind of regardless of age? So factorial designs can be really helpful for this, testing the limits of where an effect might be present or might lie. It can also help us to increase external validity. Rather than maybe testing one age of drivers or just generalizing to all drivers, what we can do here by breaking it up into older and younger groups is we can get a better generalization to the population. So if we were to test just drivers, period, we might not get a very strong effect. But by breaking it up into older and younger groups, we might be able to say that older drivers tend to not do so well when they are on their phone. And younger drivers maybe do better, right? I'm not sure that's accurate, right? But here we can talk about how it might generalize to people either of all ages, or maybe might be more consistent or more strong depending on the age of our drivers. So it helps us to test limits, it helps us to increase external validity, and it also helps us to test theories. Factorial designs can test theories which make predictions about how variables might interact with each other. Factorial designs are a perfect way to test for interaction, right? That interaction effect is one of the most kind of prominent and important things that we see. So if we're curious how 2 things interact with each other, a factorial design might be right up our alley. For example, in the book talks about this one as well. Alcohol, one theory might be that alcohol can become cognitively associated with thoughts of aggression. And so we might show people a picture of alcohol or a photo, and then we have aggressive words and neutral words, and we can look at reaction time that people are having. Is there a difference in the way that they react to photo type versus word type? Right? Again, we can look for these interactions to test a different theory that we might have. In this case, looking at aggression and alcohol, but we can take any theory and divide it up and get our different independent variables, our different cells or conditions, and then we can test it using factorial designs to see if there are any interactions that are present. We can also see here just another way of looking at it, right? So here we have that crossover interaction that we're looking at, right? So if we look at that example from the previous slide, most of the numbers here seem pretty close and similar, but we don't have the statistics behind it. If you look at the picture here, right, there is kind of a crossover. It depends. It depends on the photo type and the word type kind of interacting with each other in a certain way. So alcohol can become cognitively associated with thoughts of aggression only when they cross over. It depends on which one is associated with the other. And then we would obviously have to look at how the experiment was set up and all of the internal validity kind of stuff. But just from looking at this chart or this graph, you can go back a couple of slides. If I go back, right, and look at this image here, where that crossover interaction, it depends. So we can see that an interaction is present by looking at it in the form of a chart or a graph. So hopefully that makes sense. Again, the essence of this type of design is that we're just adding an additional independent variable. So we can have independent variables here interacting with each other, which is more important than main effects, which we can also see. And then don't forget that we can also call these like a 2x2 or a 3x3 design by looking at the number of conditions or cells that we end up with as part of our experiment. So that is it for chapter 12 here on factorial designs. Make sure that you get going on all the other required weekly materials, and I will see you all next week for our next lecture.